All right, so looking at the tool holder, we've kind of got this oddball shape, and the 0.625 by 1.25, we're going to do that with the hole wizard, mainly because if that's a drill point, the hole wizard includes it in the geometry. If we wanted to revolve and draw our own drill point, then we would have to generate a plane or figure out where this point is and make that the what would that be? Kind of where the right plane intersects, so that I could draw that revolve on the right plane and then cut that out. So Hole Wizard's a pretty decent time saver. So looking at this geometry, then it's kind of the square with the corner cut off. That's kind of a good as place as any to start. I've drawn this where I went along the bottom and extruded it up. Gone across the back and extruded it out. We're still going to end up with about the same number of cuts. So there's things in the geometry that are going to jump out at you as a good place to start. And the other side of it is, if I want this to look like the isometric, where I have some position in mind for this to go over into the assembly or in the drawing, then what is going to be the front view? What is going to be the right view? All right, so front view and right view. So that being the case, I will fly this out. This is in inches, so new part inch. And so at this point, you should be getting comfortable enough in the sketch creation that if you see that going into chapter 2, going into especially into chapter 3 in the next week or two, that you don't have to always start on the front plane. If something would look better in the top plane, if it has a better orientation in the top plane or the right plane, then you pick the right plane. So I'm going to pick the right plane. Open up the sketch, it rotates into position, and I can start my geometry. I can go to the square, draw a line across the corner, do something a little different because I don't trim as much as I used to. All right, so going into trim, if I do a power trim, everything the line crosses goes away. I don't particularly like power trim. It doesn't have as fine, because usually the things that I do decide to trim, I'm going to go trim to closest. Hardly ever use corner, trim away inside, trim away outside. If those things, if that's something that you're used to from other CAD programs, then they're there, they're available. Go for it. All right, so my dimension will be 2.24 across the bottom, height of 2 inches. And what do we have for the step? Well, I have a 45-degree here, so let's go ahead with it. This would be a good point to look at what happens with the extension line. There's a dimensioning technique that is kind of a phantom extension line. So if you pick a point and a line, it's going to give you this arrow. So if you've seen this four-headed arrow pop up and you go, well, what's that doing? Whatever direction that you pick, that will project an extension line in that wherever you're selecting to, and allow you to apply the angle, included angle, from that reference. So if it's not convenient, or you don't have, maybe this is curved geometry, you don't have something that's accessible, it will project the vertical to take the dimension off of. So 0.5, and there is my geometry. All right, so this is going to go out to 3.78. So features, extrude boss base, it rotates into position. I'll go that way, 3.78, and go ahead and accept. All right, so the sketch on the bottom, kind of rotate that in, or fly that in. So I have 2 notches to remove on the bottom. Those will just be cut extrudes through. And I kind of want to keep that frame of reference as it rotates. So drawing an isometric where I've rotated around and I can kind of see that out of position, it helps me keep my frame of reference. Which way is this going? Did I lose that frame of reference? And there have been times where I've drawn on this side and I really needed to draw on that side because when it rotated, I thought I was drawing on the top and I was really drawing on the bottom or something to that effect. So 1 square and 1 square. All right, and the dimensions are 1.14. And we have a dimension of 1 inch on the end. Depth is 0.76 and 0.54. And then we need to locate for position, so 1 inch out to the edge. And it's not so much that it's able to project, but it is an edge, it is a piece of geometry lying in that plane that we can work from. So feature, extrude cut. We'll go ahead, let's do an up to next. So when we have the angles, up to next kind of follows the angle or follows the contour of whatever the last piece of, or the next piece of geometry is. Where through all just says, whatever this last piece of geometry is, that's where I'm going. So we have the cut in there. All right. So same thing on this one. I'm going to kind of lose my frame of reference when this rotates into position. In my day-to-day design, I have the rotate sketch to normal view. I have that turned off. You know, I'll do the control 1 or I'll do the control whatever to rotate into position to get it going. All right. So just like the 2 rectangles, let's apply this back in. So just like the 2 rectangles, I could draw 2 triangles. Well, okay, a triangle with an extension on it. But this is a good one for the open profile. When I have an open profile, in 2016 they added a blind-in condition to the open profile, which is still a little weird to me, but most of the time I'm going to switch over to through all or to through all both anyway. So some of the rules for the open profile is everything has to be connected. So I grabbed the midpoint, and I did not want that. So if I do something like that, well, those are 2 open profiles because they're not connected. So when you get rid of that midpoint. So to stay with the open profile strategy, I need to connect the dots. Right? So as long as I can set my pencil down or my cursor down and trace continuously across that face, this will make a through all cut, and I don't have to draw in the triangles. I don't have to draw the closed contour region into that shape. All right, so we have 30 degrees on this side, and that's going to be from the top, and 45 degrees. We have 1.12, so 1.125 in the middle, and 0.74. So we'll do the horizontal dimension. So I took the midpoint off, but I didn't reapply coincidence, so we're going to do the select, control, select, go back to coincident, and then I just need a height for that one. And that's going to be 0.74 from the top. All right, so this is one of those cases where I picked up the endpoint. I got the line. At this stage, I can either pick one of the arrows, but that's not going to help me. So I'm just going to hit escape. Notice that the endpoint is selected. I hit escape one more time. It's going to let me stay in the dimension. If I were to hit escape one more time, then I would be kicked out. I would be back to the select and going to the next command. So I get my sketch fully defined. We'll rotate around and kind of make sure that I haven't lost my perspective. Extrude cut. and it's showing as a blind in condition. We want to do through all, and it defaults to through all both. So this is one of the places that, even though this open profile is on this back face and there's no terminating feature in the direction 2, it will still accept it. And so if I generate that geometry otherwise and said through all, and it was going into open pixels, open space, it would usually error and say there's no terminating feature or cannot extrude in that direction, and you would have to go back and uncheck direction 2. Alright, so what I wanted to get to then is the hole wizard. The hole wizard is our database of different styles of holes. Alright, so what else is under there? Oh, in 2016 they also added the thread. I would say 2017 the thread got more usable. So when we do the thread geometry with the swept cut, then we'll go take a look at that thread feature. So on Hole Wizard though, we're going to end up with cosmetic threads on our geometry. Alright, so at this stage I haven't pre-selected anything. Alright, normally I would pick the face that I want the hole to go in on. And what is the hole type? Counterbore, countersink, simple hole, straight tap, tapered or pipe tap. And then you get into legacy, which is defining the geometry. Right, so previous to what, 2004 or so, you might run into legacy hole as the only option. Then they, within the last couple of versions, they added the counterbore slot, the countersunk slot, sink slot, and then a slot as a hole wizard item. So the advantage of using the hole wizard is my what if scenarios. I go through the assembly, I build everything up, I get down to the end and I see how everything fits together, and I realize I can't put it together from that direction. So if I draw all of this geometry as cut extrudes, as revolves, I have to go back then and change each one of those pieces of geometry to something else. If I do it with the hole wizard, I can go from a tapped hole and say, well, tapped hole in that part doesn't help me, I need to reverse it, and it's going to be a counterbore this time, or it's going to be a simple hole. And I can transition from one type to the other just by selecting one of the other icons. Right? So in the case of the stack up then, I can go back through it. It will retain its point locations, and I may have to select other faces for it to sketch on, but for the most part it's going to be reasonably decent geometry to change over. Alright, so we're going to do the simple hole, and we're in the inch standard. Alright, we have all these other standards. Typically what I do for my commercial version is I go into the hole wizard settings and I turn a bunch of things off. And then there's a couple of things that I go further into the database and I turn them on. So just because you don't see a thread form that you are used to or that you would use in your industry doesn't mean it's not there. It's just not active. All right, so they go up through quite the list, but not to everything. So we have the standard inch size, and then I want a type of fractional drill sizes. This is called out as a 0.625, which we know is a 5/8, but I can also say show decimal values. And for each of the fractions then, I'm going to scan down until I see 0.625 and build from there. Be careful with the show custom sizing. It will let you override the defaults. The problem is this is still going to read as a 5/8 hole. So if you want a 16 millimeter, 0.6299, whatever it works out to, 0.63, and you change this value, it's still going to show me that it's a 5/8 inch hole. Now that's within the tolerance standard of most drill operations, but if you made a wide swing, maybe there's some value that you want to adjust this to. try to find that value rather than adjusting the custom sizing. Because I may, as a machinist, I take this part and I put it into the CAM package, and the print says it's a 5/8 hole, or the dimension shows it's 5/8 hole, but then I go to measure it and they're different. I want to know what's going on. Okay, why is there discrepancy? Which one do you really want as the designer? And it's a 50-50 shot most of the time. So, half the time the designer will say, "Oh no, I just changed that real quick to see what would happen." It's really the dimension on the print. And other times it was, no, you need to build it to the model. All right, so if I can't, if I don't see that alignment, I'm going to raise the question. So try to stay away from manipulating custom sizes. Our up to next, this is going to be a blind condition. And the little icon is showing to the shoulder. So what is the depth minus the tip of the drill? All right, so whether it's a 118 degree included angle drill bit, 135, 150, whatever the different tip geometries, what is the depth to the shoulder of the hole? So we're going 1.25 deep. Near side countersinks mess with CAM packages. So if it is a large, okay, so I want a 16th lead-in, or I want a 32nd lead-in. Okay, go ahead and put that as the near side countersink. If it's 5/1000ths, the CAM packages are going to have a difficult time picking up those edges, and we're going to see a lot of duplicate geometry that maybe isn't necessary. All right, for position then, because I didn't pre-select, it's going to ask me, select a face, or do you want a 3D sketch? And when we get to the revolves and we get into the cylinders, we're going to look at the 3D sketch, because there are two strategies. One of them is really stable in the 3D sketch. The other one is functional, but it's kind of a pain. All right, so I'm going to recommend that you generate a plane and you control those cylindrical, any hole going through through a cylinder with a different set of geometries. All right, pick on the in face. It shows the preview, and with the hole wizard, wherever you place a point, you get a hole. All right, so I can place 20 points, and I will get 20 holes. The problem is that all of the points that are outside the bounds of the part, they're not going to do anything. All right, so we can either escape, right-click and select, or just jump directly into the dimension, and we'll go 0.76. And from the bottom, 0.62. All right, so way back when, in the first couple weeks, we did a hole pattern, a circular pattern. And one of the things with the circular pattern is it puts a point at the middle of the pattern. And it does it by default, and you may or may not realize that it's there. If we are circular patterning for the hole wizard, these points, and I want eight of these holes in my pattern, when this goes over to the drawing and I do a hole call out, it will call out 9. And if it's an open pattern where the center hole isn't there, technically isn't there, it's a hole into an existing pocket, into an existing hole, then it technically doesn't exist, but it will still get counted. All right, so if you use that as the hole wizard, just be aware that there is that that point. And typically, you go back in, you delete the center point, and it doesn't affect the sketch very much. You may have to reapply one relation, and it goes on. All right, so what did this do? Let's go into the section tool. And for the section tool, we'll pull out a little ways. And there is my drill point. So if this was a threaded hole, we would see a simplified thread form. We'd see dash, 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 and that would be the major diameter of the thread. With the counter bore, we would have the cylindrical relief. If it was a countersink, then we would have the conical relief. All right, and then to get back out of the section view, we just hit on it again. It comes back to our part. So let's go ahead and save that one. The last one in that section then is interesting for the limit dimension. Let's see, I went to public. And what are we on? No, this was 6.58, so F 658 tool holder. Okay, so we'll go ahead and close that out and fly our sketch back in. Okay, so the last one on this sheet is the index feed. We're not so concerned. We haven't done anything really with the materials, but called out as brass, cold rolled steel, C1, cold rolled steel. Yeah, everything's pretty much cold rolled steel. So 1018, pretty much a standard cold rolled steel that we could assign to the parts. So we'll give it a little more before we start putting in the materials. Okay, so pretty much standard dimensions until we get to this where the tab is going to sit in a T-slot or has some engagement into another part. So the 0.75, 0.745, that limit dimension, we want to apply out of the drawing. And one of the reasons that my dimensions are purple as opposed to black is that I have turned off mark all of the dimensions that I include for the drawing by default. Right, so this would be a dimension that I would want to mark for the drawing so that when I take it into the drawing and I say insert these items, I actually get the one that is critical, the one that I want to identify, or ones that I want to identify and be able to use. All right, so we have a half-inch clearance. And we'll see where that falls out as a in the standard. So let's go ahead and fly that out. Oh, as far as the shape of this this block, pretty much on this lower edge, we're symmetrical about that the limit dimension. So I'm going to go ahead and keep it. It's interesting to me that they put a 2 decimal place and then a 3 decimal place that amounts to, you call it plus nothing minus 5 thousandths or plus or minus 2.5 thousandths, you know, however you want to run the terminology, but that it goes to a 2 decimal place and allows it to float possibly 10 thousandths in that that position off of center line. So new part, we're still an inch, and so using the symmetry, I'm going to go into the center line, vertical orientation, infinite length, place it on the origin. We'll start off drawing that that tab, come up and over, and then pretty much at that point I'm going to go right to left and mirror entities. Alright, so starting off with that that limit dimension, what do I want for my selection? Knowing that this is going into manufacture, if I've had the conversation with the machine shop, with the machine shop manager, with whoever is the decision maker in that group, I'm going to probably go by default to maximum material condition unless somebody tells me different. So maximum material condition in here, in this case, is the larger number. So I want to draw this to 0.75, and then the limit dimension comes in and says it can be as small as 0.745. If I draw it at 0.745 and I send this to the CAM package and it machines to those edges, you've already machined to the lower limit. There is no place else to go. All right, so if it misses, if the tool is on size or whatever happens in the selection, you've used up all that tolerance before you've ever even cut the first part. All right, so I want to give the machinist, the ample opportunity to make adjustments and be able to hit that tolerance. So maximum material condition is what we're going to be looking at. So the counterintuitive part of maximum material condition is if this was a hole or a pocket that had this tight tolerance, then I would want the smaller number. Smaller number means more material in that hole. Okay, so we'll identify a few of those when we get to them. So 0.75, and what I jumped over here was in this modify box. Let's see, reverse. At the tail end, there is marked dimension to be imported into a drawing. All right, so right now my dimension is purple. When I select and hit OK, my dimension will turn over to black. All right, we're going to see what that does when we take this over into the drawing and import the dimensions. All right, because our strategy is still we're going to design for convenience, and then when we get into the drawing, or in the case of the manufacturing or model-based definition, model-based dimensioning, that then we'll put dimensions on it that make sense for manufacturing. All right, so when I pick this this one dimension, we have the styles, we have the tolerance and precision. I can put in notes to a certain extent, and then different, what do we have? Centering the dimension between the lines, offsetting the text, justification, additional symbols. For this one item, we can dual dimension. Then goes over into the leaders, goes over into other. Right, so what I'm interested in is my tolerance and precision, that this is going to be a limit dimension. Basic dimension, so for GD&T says it is theoretically perfect at that dimension, and whatever the tolerance zones on the control frames, that will control how that geometry can be adjusted. Bilateral, plus nothing, minus 5 on the end of the dimension. Limit, we're going to see the two numbers. Symmetric is just the plus or minus 5, whatever we're doing. Min, max, and fits. All right, so pretty much we're going to stay bilateral, limit, and symmetric if we need them. Everything is assumed on the from the drawing, plus or minus 5 thousandths for, plus or minus 10 to 15 thousandths, depending on company standard or organizational standard, on a 2 decimal place dimension, plus or minus 5 thousandths on a 3 decimal place, and then depending on level of tolerance, anywhere from a couple of tenths to 2/10 of a thousandth up to a thousandth on 4 place decimals. So for 4 place decimals, I typically did plus or minus 1,000, mainly because if it was something that was really that critical, that had to be gauged to a higher level, then I would go in and I would put a specific dimension on that geometry so that we could still stay within the range of what our machines are capable of and what we're capable of measuring. All right, so I go into the limit dimension. We're not adding anything. While I'm here, I'm going to go ahead and for the primary dimension, we're going to go to 3 decimal places. And the minus on this one is 0.005. Okay, so once that goes into effect, then I end up with the higher number, 0.75, over the lower number, 0.745. The dimension, or the line, is still 0.75. All right, primary value, the dimension 0.75, and then nothing really in the way of notes. So we can adjust leaders to be outside, inside, and then the smart and other. Right now we haven't generated any read-only or driven, but we can also toggle the driven state of a dimension. All right. So be aware that those exist and how we can utilize them. All right. Alright, so 0.19. And let's see, the 0.62, let's fly that in so we can look at some of these dimensions. 0.19 on the bottom of the tab, 0.62 to the upper. Alright, and here's where we kind of run into the stack up of tolerances. You know, are we dealing with 0.1875? Are we dealing with 0.625? If there's going to be an issue, now's the time to identify it. Now on the design side, no, I need to really switch this over to 3 decimal places and control these outside of those decimals. If it's not going to be an issue of the buildup, because on the machining side, I get this print and it says 0.62. I'm going to make it to 0.62 as close as I can hold it. Alright, so 3.25, and that gives me my geometry. I go ahead and extrude boss base. I'm going to go to midplane and set the part at centered on the origin, and the depth is 2.5. All right. For the side, then we'll pick up the edges. Basically, just trace over the top of them. Come out here some distance and up, and close that off. Alright, so 0.25 on the ends. We have a distance of 40 degrees, or sorry, an angle of 40 degrees, and then we are 1.25 off of the back edge. Now in this case, I could do the math. We have a dimension that says this is 1.56. Right, so I could go 1.56 minus 0.19 minus 0.62. That's way too much math. I want to utilize one of my end conditions that says I'm going to extrude this boss base. It's going to be 1.56. I would like the direct number. And I'm going to offset it from a surface. So when I pick the surface as the bottom of the part the dimension was taken from, well, we need to reverse the direction. And, well, we're not really doing anything with the offset. And yes, we want to merge the result. Translate surface would be if this had curvature or a wave in it or an angle, then it would also pick up the angle geometry or the radial geometry. Alright, so after I do that, I want to double check my number. So I'm going to do the select control select of the faces, and it tells me that there is a normal distance of 1.56. My chamfer then, let's see, chamfers usually go in last, so let's put in a few more geometry before we get to it. Alright, so the triangle out of the bottom right corner has 50 degrees. And we have a distance of 1 inch. And it is going to be cut in a distance of 0.19. Alright, and then last is the hole wizard. So we picked the hole wizard from the command manager. This is a great place to use the S key. If you haven't started using the S key, then hit the S key every once in a while, because the S key will have the hole wizard, it will have sketching commands, it will have features. I added the measure and the mass properties to that location, and so when I hit the S key, I can go directly to the hole wizard without having to go back to the command manager. We're going to generate a counterbore. It is going to be for, well, we don't know what it's going to be for yet. We're going to assume that it is a, let's see, they did a depth of 0.35. It's probably a hex bolt then. I'm going to say the general rule of socket head cap screws is whatever the diameter of the socket head thread form, that will also be the height of the head. All right, so when I look at 0.35, that's not all that close. So we're going to go see what 7/16 looks like and show the custom sizing, not to necessarily change it just yet, but to see where it comes out. So this one came in at 3/16, 1 inch on the head, and a little over 7/16 on the clearance. Probably not a hex screw. Oh, it jumped back to. All right, so different sizes only go so far. Square head bolt, probably not. So we discounted the sockets, the pan. So still not quite working out. I'm going to stay with the hex bolt. Well, we'll try one more. The heavy hex. Heavy hex starts at 1/2 inch, so clearance and everything else don't quite line up. Nope, they're staying in the same grouping, so, and still didn't get up to that level. So, all right. So 7/16. If I wanted to match their numbers, then this is a place where I can show the custom sizing and modify the numbers for what we want to generate. So we have a clearance of 0.5. Counter bore is 0.75. Depth is 0.35. And we're going to be going through. Oh, I didn't look at the close and the normal and loose, so let's see that real quick. Close brings it in tighter and doesn't really make any real changes. And then on the loose fit, got a little bit closer, but still not really what I wanted. So 0.5, 0.75, 0.35, and then scrolling down, we still have blind in condition. I want that to be through all. No head clearance, no near side countersink, no under head countersink, no far side countersink. All right, so we have these additional geometries that we can build into that definition. Going to the position, because I picked the face before I went into the hole wizard, all I have to do is place the point, and that's going to get it started. All right, so we're 0.75 off of the front edge, and then positioning wise, I could grab a midpoint, but we have the origin. So the only real issue with the origin is I need to be looking at the origin. So normal to the sketch, and we'll make that vertical. Okay, and go ahead and accept it. All right, so my general strategy or my preferred workflow is chamfers and radiuses go in last. So even in this case, where it's just a 30-degree relief on the backside, if I'm going to use the chamfer tool, I'm going to put it in last. All right, so up to the chamfer tool, and we have a distance of 0.94 with an angle of 30 degrees. All right, so based on the preview, that is not the correct solution. So we'll flip the direction, and that one looks pretty good. So we'll go with it. And go ahead and save. And this is going to be the index view. All right. So I said when I bring this over into the drawing, And this will kind of be our jumping off point that if you want to start making drawings, you can go through this process. There's a couple of, again, a couple different ways to get into the drawing. I think a lot of the companies and people I've talked to have switched to the view palette as opposed to the insert. So we can open up a new drawing, or I can say make drawing from part. So if I make this drawing from the part, it's going to ask me for the template. Well, this folder didn't end up with any. Yeah, we'll just go to the drawing, and because the template hasn't been, well, I don't know that the template hasn't been modified, but we'll find out here in a second. It's going to come up and ask you for a sheet format and size. So I'm going to go with the A landscape, and we'll pick that. And we've been set to switch over to the view palette. So the view palette is over on the task pane that we've kind of jumped over as we went through the parts. What this is going to do is allow me to drag and drop the views that I want as I generate. So there's the front view. It switches into projection mode. I get my 3 views. It added the center line for me. And then all I have to do is go about scaling. All right, so there are 2 or 3 videos, and I will probably do the template modification thing tonight for the advanced class. But the standard SolidWorks templates kind of use up a lot of space on the A style. There's a couple of different ways to approach, and so most of the time I would lean towards a B size rather than the A size, but we can make some adjustments on scaling and put our start putting our dimensions in. All right, so I haven't set anything up in the way of layers. I haven't set anything up in the way of fonts and styles or anything like that. On the annotations then, under model items, what we're kind of working towards is I'm going to go to the entire model. And if I had every dimension that I put into this model marked for drawing, then everything would come in. So the second icon here is bring in dimensions that are not marked for the drawing. So let's look at what happens when we just go for marked with drawing. I go ahead and hit OK. There's the 750, 745 limit dimension that I thought was critical. That's the only thing that comes in, and now I'm free to dimension the rest of the model based on manufacturing. If I go back to model items and I switch over to not marked for drawing, let's see, into all views, then this one isn't too bad. It's manageable, but probably still isn't my preference for dimensioning, detailing this view. All right, but I do get everything in from the model. In the worst case, if this is a really complicated model, I get a rat's nest on top of this that I have to go through and decipher a ton of dimensions, and it's not any great advantage to have to go through that process. Okay, so I'm not going to save the drawing at this point, but we would go through, set some layers, apply a few more tolerances and dimensions. There is a hole call out, so we don't want that one on the model. Let's see, the 50 degrees can come out. All right. So for the hole call out, we'll recognize the hole wizard geometry. So when I pick on that hole wizard geometry, it will give me the designation for the 1/2 inch through, the 0.75 by 0.35 deep, as opposed to me setting up all of those symbols and in that dimension. All right. So not going to save the drawing, but we will save the part. We'll come back to it later as part of our dimensions. All right, so that was the kind of the first sheet out of the technical drawing. I want to go into some of the revolves. All right, so with a revolve, we're going to be setting our axis of revolution. And when we look at these section views, it is pretty much this quarter. So if we cut the part in half and then we cut it in half again, this is really the only geometry that I'm interested in, is what is in that profile. All right. When I revolve that around the my axis of revolution, that's what's going to give me my geometry. So if the center line and this line are on the same are collinear, then there will not be a hole. If I open it up and leave a gap in between the center line and the outside line, that is what's going to generate hole geometry included. So this one is called out as a 1.498 to 1.50. All right, so from a maximum material condition, I'm going to go to the 1.498. All right, so that geometry, to make it look like the isometric, that's going to be in the top view. So new part inch, top plane, open up the sketch. Did I grab another? I grabbed one of my other default part templates then, because I don't have the grid normally turned on. And I think all last semester I said I was going to turn that off and save it back to the template, and never did. So vertical infinite length, place it on the dimension, and we're going to kind of have this L shape. It's up to you if you want to include the radiuses and the chamfers in this sketch, but I would tend to put those in as features rather than fight them into the sketch. All right, so first dimension, and this is where we really get into the radial and the diametral dimensions. So picking on the center line and going to my object line, if I stay in between, I have the radial dimension. I go opposite, I'm going to get the diametral dimension. Radial, diametral, radial, diametral, radial, diametral. I just like saying that. 1.498. All right, so that's going to give it the maximum material condition. Chances are that's going to be a really big reamer, or I'm going to have to bore, set that up on a lathe and go in with a boring bar to hold that tolerance. But again, if I'm sending a CAM program and saying cut to this edge, I want to start where there is the most material, and in the case of the hole, that is the smaller number. Nope, larger number. Smaller number. I have to think about it. All right, overall height, 2.12. And by default, once you start into the diametral dimensions, it will stay there. So we're going to go ahead and put in a few more. What do we have? 2.76. And then the outside is 5.5. All right. So when I get back to that linear dimension, I'm going to have to hit escape, and that will let me out of the diametral dimensions. I'll go 2.12, and last dimension 0.75. Okay, so that's my shape. Now I could have built this as a boss extrude with one circle and then extruded up the other circle, but I am going to get a certain level of control, and as these get more complicated, I'm going to be able to build in more geometry that I'm not going to be able to build in by stacking up boss extrudes. All right, so instead of extruded boss base, we're going to jump over one and go to revolve boss base. 360 degrees, there's my geometry. So I'm not sure if the section view, section view isn't quite doing the quarter yet, but let's go ahead with the top. So by going through the cutting it in half again, here is my sketch. This is really the geometry that I'm concerned with to make that revolve, which looks remarkably like Oops, like that.
This one's out there too.
All right, so we're not going to put the fillets and rounds in until we have the rest of the geometry. I'll turn the section off. Typically, if I needed to switch this from simple hole pattern to a counterbore or countersunk hole pattern, I would be doing it from this this face, or the assumption would be from the outside face. So I'm going to hit the S key, go into the hole wizard, and then pick the simple hole. Because I customized the sizes on the last one, it's asking me, do I want to keep? Now go ahead and reset. If I was using that custom style enough, that would be where I'd want to, let's see, is it in this one? Yeah, I'd want to set it as a favorite. And whatever those little tweaks were, I could pull them back up from the favorites. All right, so this is going to be a, let's see, 4 times, that says diameter of 5, but I'm pretty sure it's going to be 1/2 inch. So fractional drill sizes, size of 1/2 inch. Don't need the custom size. Through all is okay. So in the note, through all will show a through designation, where up to next or blind in condition will show an actual value, even if it is the thickness of that leg. All right, so position. I want to set up a bolt circle, so going into circle, dragging it out, and we'll go to for construction. All right, and then the bolt circle is 4.24. And to get that one defined, then we'll go back to the origin and set it to horizontal. All right, so when I go into the circular pattern, so linear sketch pattern, pull down, circular sketch pattern, we're going to have 4 items. I can say, well, we don't really want to dimension the radius. Let's go with the angular spacing though. It needs the pattern is the point, and displaying the instance count. I'll go ahead and make the selection. All right, so if I highlight, you can barely see it, but it did highlight the point that is at the origin. So when I take this into the drawing and I do a hole call out that gives me the instance count, I'm probably going to see a fifth call out. So with circular patterns like the linear pattern, we have to add one more relation or one more dimension. So I'm going to set the angular spacing center line to vertical. And let's see, what did it miss? And then by dragging one of the points, I can see that we're not coincident to the bolt circle. So I'm going to drag it back. Well, maybe I'm going to drag it back. We'll grab one of the other ones and make it coincident to the bolt circle. That's going to allow the sketch to go fully defined. All right, our radius and rounds of 0.12. So pre-selecting the faces, when you're dealing with fillets and chamfers, be aware that when you fillet a face, you are filleting everything that is on that face. So including the holes, including the interior, exterior edges. So a best practice, or practice to get used to, is pick your edges. And when you pick the edges, you'll also get this pop-up that allows you to utilize selection filters. All right, so we'll go ahead and put in those 3 edges. And this one gets saved as 741. And set up as a bearing. Did they give a material on that one? No, I don't see a material. That'd be a good one for the bronze or some of the other bearing material. So make drawing from part. go into the drawing, pick the landscape. Let's see, I want the front to come in. And I'm not going to worry, well, let's go ahead and bring in one more view. And we'll go ahead and accept. And what I want to check, or what I want to see, is when I do a whole call out, I did call it out as 4. So either it got corrected, or it didn't put it in because I set for the angular spacing. So this 4 times, if you were to see 5 times, when you know darn good and well that there's 4 holes there, that is when there would be, you would want to go back in and delete that center, that point that was coincident to the origin. Get rid of it. Okay, so either it got fixed or it's it didn't generate it in this instance. All right, let's do one more. We have the cutout. This one really doesn't have any of the tight tolerances, but it does have the combination of the boss extrude, or the cut extrudes going through the center. Oh, this one does have a bilateral dimensions, so let's go ahead and utilize that one. All right, so I'm going to still stay with the revolve. This is an inch part. We're going to the top plane, and I need to turn the grid off. So I'll go to the view settings, and we'll get that one turned out of the way. Vertical infinite length on the center line. I'm going to include the hole geometry, so pretty much the same L shape we just generated. All right, so kind of missed there, so that needs to be horizontal. We'll make that coincident. The through hole then is 1.372. All right, so radial, diametral. And I'm going to apply it, and then I have to think about what it's going to do to the dimensions. So this is a plus 0.003 0.003 and minus nothing. All right, so my maximum material condition will be the 1.372. So I want to switch this over to a 3 decimal place dimension. And for the tolerance, we're going to set it to bilateral. And I'm going to give it the 0.003 as a plus to generate that style. To get it marked for the drawing, I'll double click on the modify and go to the end. The other thing that I can do is right click, and there in the right mouse button context menu, there will also be a mark for drawing. All right, so I kind of reserve that mark for drawing for these things that are tight tolerance, out of the ordinary, something that I don't want to forget that I did, or I need to specifically to highlight. All right, so in overall, let's see, we got out of the dimensions, so I should be out of the radial as well. Radial diametral, 2.62. What do we have for a step there? 0.62. Going back into the diameters then, 4.75. And the outside is 2 inch. Okay, and we'll go ahead with the revolve. Okay, so this one didn't get any fillets and rounds, so we'll go back to the front, open up the sketch. And I'm going to include the interior radiuses outside of the sketch geometry. So I'm going to start with the rectangle. I think based on this this shape that I'm going to go with the contours and regions. So we have the have a rectangle as our base shape, and the height is 1.24. Still looking for the width. 1.12. Okay, let's make sure I'm reading that right. So 1.12 on the outside, and then the 0.56 is the half dimension to center it. Oh, and then radius of 0.24 coming back down, so okay. So a center line up to the point. And that notch will be on the bolt circle. Alright, so well, yeah, we'll just dimension it as the radius. So the bolt circle is 3.38 divided by 2. And I'm going to do a center point arc. Go through the angle. Draw the two lines with a dimension of 0.24. And then your choice if you want to trim or leave it as is. And all of this geometry will get cut through. So extruded cut, it's going to go automatically to contour and region. I'm going to set for through all. And if I'm going to have to pick that many regions, then I really want to go with one contour that is the rectangle and one region that is the notch. And then we'll go ahead and accept it. Alright, so if I set that right, 338, then I should be able to open up a sketch for the counter bores. Oh, sorry, the hole wizard for the counter bores. And this one I'm not going to worry about patterning. We are going to pick up the counter bore tool. It's called out as a 0.375 through and 0.3 deep. Now we'll see what the socket head cap screw looks like for a 3/8 with a close fit. And when I show the custom sizing, it's still a little oversized of theirs, so can't imagine, well, that could be a loose fit for a 5/16. So let's jump back to one level below. And instead of close, let's go to the loose setting. So 11/32 through. Yeah. Still not, that is either really, really close to a 5/16 or really close to a 3/8, but probably not. Alright, so I'll say your choice when you're running through these. I would tend to lean towards the standard out of SolidWorks than from the drawing, unless there was some specific fastener reference. So 386, 0.625, and 0.375. Alright, well, we'll see what that looks like. So positions. Going back into the circle. It's going to be the bolt circle once we set it for construction. Control select coincident. Select control select coincident. Select control select coincident. And then there's not really a point here. So let's see what happens if I go back into the cut extrude. Let's see, we're going to be able to show that one. Nope, it's not going to pick up that endpoint. So I'm going to leave that temporarily. Did we get horizontal? No. So select control select horizontal. select Control Select for vertical, and then I'm going to get out of that sketch, and I want to be able to see see where that point was, because I'm going to let this location, since it's on the bolt circle, I'm going to let it drive the location for the hole wizard items. For something quick like this, I can edit the sketch and not go back into the hole wizard, but as a general practice, you're better off going back into the hole wizard to make those edits. And then we can hide the sketch. Alright, and then the last of the geometry is the internal. And that is a fillet of 0.12. Alright, so the downside of the two-place decimals on the 0.12, since it's drawn at 0.12, again, going into a CAM package, going into something that's going to program for a machine tool to cut that, it's not going to put a 1/4 inch tool into that corner. 3/16 you would be able to generate. You'd be able to generate that exactly 0.12, but the variation on the tolerance zone, if I was designing this, I would round up rather than round down. Go ahead and give it a 0.13, so even a 1/4 inch tool could travel through that radius with a very small turn, as opposed to coming to a complete stop and changing direction. All right, so minor details, but if you have some of the manufacturing, how this is actually going to get made, thinking about these tolerances, you can make better decisions. All right, so this was 744, and this is a centering bushing. We'll go ahead and save it. All right, so when we start into the drawings, we're going to be bringing these in and going through through some of the detailing, and we'll build out more geometry, get more into the detailing side next time.